to wait for any longer. I just hope that students will try to take advantage of these office hours because I'm going to be giving lectures, providing guidance on how to do the homework problems. This is what the office hours will be. It's not just office hours for questions and answers, because I understand it's clear to me this subject is not one where you can just read. I mean, some people can, others may not be able to. And so I try to provide lectures and guidance, lectures on the subject matter, and also guidance on how to approach the homework problems.
Okay.
This is a course that is really designed for majors in business and financial economics. And so it's not just like a class that people take casually. You must show interest in the subject of statistics and application to actually register for this class. So this is why we don't have too many people in it, but that's fine with me. So I will proceed. First of all, how are we going to conduct this class? I'm going to conduct this class every week on Zoom on Tuesdays from 6:30 to 8 p.m. So try to take advantage of the lectures. Secondly, of course, all class materials are posted on Blackboard. And so please submit all your assignments on Blackboard. Also obtain all your assignments on Blackboard. I will post announcements every week as to what we should expect to do during that week. And so please look out for announcements and try to follow the announcements. There will be one midterm exam, and then there will be one final exam. The final exam will have two parts to it, a multiple choice part and a problem-solving part. Now, throughout the semester, we are going to also do homework assignments. We might do some discussions, but certainly there'll be homework assignments every week. There'll be quizzes every week. And the homework assignments really require that you practice and try to understand the principles of applied statistics. And so what will happen is when I give the lectures and the guidance, at least you have an idea how to approach the problems accurately. And this is why I provide the office hours. Okay, no assignments to be accepted by email. And I try to tell students this, but very often when a student misses a deadline, they say, see, I did the work. Here is my assignment. I will usually reject them. If they are submitted pretty close to the deadline, I will open the assignment and let you submit. But please try to submit on time, because once I grade the assignment, then any late submission will be very heavily penalized. All right, so having said that, do you have any particular questions on what I said so far? Do you need clarification?
Oh, I understand.
Okay, fine and good. So we can now move on, and I'm going to use this opportunity to pull up a little PowerPoint slide to explain the subject. This class, ECON356, is a second level class in applied business statistics, second level class. And the whole idea behind it is that it builds on any course that you have taken in elementary statistics. Okay, it builds on any course you have taken in elementary statistics, and the emphasis in this second class is inferential statistics. Okay, so when you study statistics, there are two components. There are two types of statistics, statistical analysis. One is descriptive statistics, which is the basic thing that we do. We summarize data, we present the data. And it's simply a summary, broad summaries, or summaries of broad averages, standard deviations, and other statistical parameters, depending on the level of sophistication and what you want to interpret. Then there is inferential statistics, which is really what occupies the statistician for the most part. Okay, inferential statistics, begins by let me put it this way: inferential statistics is where you use sample information from a sample to make judgments about, or to make inferences about the population. So with that, let me try to share my screen and see if okay. I often begin by saying to people, what is statistical analysis? What is it about? The definition that has stuck in my mind was given by my very first professor of statistics when I went into business school many, many, many years ago. That statistical analysis is the collection and analysis of unorganized mass data. Mass data meaning large quantities of data, but collecting and analysis of unorganized. Now, why do we say unorganized? We say unorganized for the simple reason that everything that we do creates a statistic, creates statistical data. Okay. Everything that we do creates statistical data. What time you wake up in the morning is statistical data. You woke up at 7:15, you woke up at 7:30, you woke up at 5:30, you woke up at 9 o'clock. All of it is statistical data. What you eat in the morning, or even whether you ate breakfast, is statistical data. The number of cars that cross the intersection, how long it takes you to get to work, the distance from your house to work, and whether actually you went to work from your house or you went to work from a different location every morning on a particular morning, they all create statistical data. Now, but the point is that this data is not there organized for somebody to analyze it. No, somebody has to deliberately define a problem, define a set of variables, and then collect data that is already there, but not organized. Let us say we ask ourselves a simple question: about what time do most people wake up in the morning to go to work? Well, the numbers are already there, because every time somebody wakes up, it's a time. It's a time that is there. Time is there, 7:15. That's when one person woke up. The other person woke up at 7:30. The person woke up at 9 o'clock. The person woke up at 6 o'clock. It's already there. That time, 6:30, is there. It happens every day. But how does it reflect something that somebody did when they woke up, when they ate breakfast, when they made a phone call, when an accident occurs? So time is given, it's there. So we define a problem: what time of morning do most people wake up? That is a problem, okay? And so the variable, the time of morning, all right? That's the variable. And then we want to collect data. And there are so many data that has already occurred when at 7:15. Okay, how many people woke up there at that time? Then how many people altogether woke up to go to work? Okay, and each person that wakes up is data. Are they male? Are they female? Are they what age? Are they young? Are they teenagers? Are they young adults? Are they mature, middle-aged executives? All of that is data, but it's not organized. But once we define a problem, and we want to know, are there categories of people that wake up at 7:15 as opposed to those that wake up compared to those that wake up at 9 o'clock? Okay, and why so? So we have defined a set of problems, and we have defined variables, categories of people, all right? Right there, it's a variable, categories of people, the genders of people, they're variables, okay? All right, so that is why we talk about unorganized. So we organize the data. We collect it, we organize it, then we analyze it, then we present it, okay? Actually, we analyze it, and then we summarize it, and then we present it. And after we present, then we make a decision. So now in doing that, we have two kinds of statistics. And I just gave you an example of applications, trying to categorize how different people wake up, all right? See, in this slide, it says that numerical information is everywhere. It's everywhere. Numerical information is everywhere. So statistical data is everywhere, okay? And of course, there are different people that use statistics in accounting, in marketing, in agriculture, okay, in medicine, healthcare, okay. So we have two types of statistics. There's descriptive statistics, which I said. For example, if you collect all that data on when people wake up, and you categorize the data according to young adults, according to blue-collar workers, according to executives, according by gender, okay? And you summarize the data and say 10% of females wake up between 7:15 and 8 o'clock. But 25% of males wake up between 7:15 and 8 o'clock. That is descriptive statistics, okay? Now, so essentially you summarize the data. Then there is inferential statistics, okay? Inferential statistics is when you use information from a sample to make a generalization about a population. So now we differentiate between sample and population. How do we define a population? Okay. Now, a population includes every member of a defined group. For example, all the registered students at Meg Evers College define the population. When you count every single registered student at Meg Evers College, that's a population. Now, if you come into a classroom and take the students who are in that classroom and you say, what is their average height? What is their average weight? What is their average income? And so when you come to a classroom and just take the 20 students you see in that classroom, you have taken a sample. So a sample is a subset from a population, okay, a selection from a population. Now, and so if you take that group of students, 30, 40 students in a classroom and say, let me find out the average income of these students. And you get and you summarize that data, you have done descriptive statistics. But then if you use the information, for example, if you say the average income of a Meg Evers College student based on this sample is between A and B, between 15,000 and 30,000. You are now doing inferential statistics, and there's a method for doing that, okay? Which, of course, we're going to discuss in the next week. It's a method for doing that. And so, but sometimes you ask yourself, why then do we use information from a sample to make inferences about a population. If you wanted to get all the registered students in Megabus College, it's easy. You go to registrar's office and you find all the registered students, okay? But sometimes population is difficult to define, and population is difficult to control. For example, if you were to take a fish pond or a fishing area. Now, the fish in a fishing area could have certain clear characteristics. They could be large fish, they could be small fish, okay? There could be fish of a certain weight, of certain length, but you could not easily define their population. You cannot exactly say this is the population of the fish because the fish come and go. Nevertheless, they have a particular characteristic. The fish you can see in a fishing area could be an average of 10 ounces or 2 pounds. There could be an average of 2 pounds. So if you randomly pick any fish from that pond, the fish will weigh about 2 pounds, give or take a few ounces, give or take. So whenever you come into that fish pond, whatever you get there is going to be a sample. You cannot truly define the population, even though the population may actually have certain kinds of characteristics that could easily be measured, okay? So we rely on a sample to make inferences about population because very often population is difficult to define. For example, what is the population of Brooklyn? You couldn't quite say that, okay? Couldn't quite say that because people move in and out of Brooklyn every day. So you couldn't say this is the exact population of Brooklyn, okay? So population is difficult to define, and sometimes trying to use information from a population could also be very costly, all right? If you wanted to know on this snowy day, how did it affect students coming to school at Megabus College? What was the average arrival time to school compared to on a day it did not snow? Now, what is the population that you're talking about? If you look at a typical day, what do you call a typical day? But let us say you take one particular day and call it, okay, well, using this day. Even on that particular day, the only way you can get a population is to call every Megabus College student and ask, did you come to school today or not? If you get that accurate information, then you have a population to be talking about, okay? The same thing on a snowy day. You take one particular snowy day, you have to call everybody who came to school that day. And how do you know who came to school that day? But one thing is very clear, because of the snowy day, definitely it affected how quickly people got to school from the time they left home. And you can make an inference not only about the average travel time to school, but you can also make an inference comparing a normal day to a snowy day. All right? Okay, so that is the kind of thing that we do in statistical analysis. This class is going to focus on inferential statistics, okay? Like I said, the difficulty with trying to call everybody to find out whether they came to school in order to define the population can be very costly, okay? Can be very costly. It might also not be quite reliable, okay? So, now, having said that, okay, like I said, this class is going to be more about inferential statistics. And so I just essentially gave you an idea what we're going to be doing and how we're going to be doing it. As the semester progresses, we're going to be applying methods of inferential statistics. But also, there are ways of thinking in a statistical way, okay? So I'm going to pull up another set of slides, and I'm going to post these slides in my I'm going to post these slides for students to see what we did today. And the slides are there anyway, so you can use them. I'm going to use this opportunity to talk about how we reason in statistics. So I'm going to pull up the questions we have for discussion so that you would have an idea how to resolve statistical questions through some reasoning. Okay, I'm going to pull that up. This is one of the questions that the question in the first discussion. Okay, this is the question in the first discussion. I'm going to make it bigger so you can see it. All right. There's a question in the discussion, and I'm going to use this to illustrate how to think statistically. Okay. It says that in this real estate company, the managers would like to explain whether there are differences in the price of houses in two locations. This is an example of the kind of thing we'll be resolving throughout. But now let us think about it intuitively before we now get to the methodology, which will come in the next 2 and 3 and 4 weeks and for the rest of the semester. Okay. There are two school districts here, Eastville and Apple Valley. Okay. Now, Jack and Jill and their manager, Pelowada, would like to understand whether any differences in the price of houses in the two districts can be explained by buyer's preference or can be explained by differences in the average age or average size of houses in district. Why is it that houses in district Apple Valley are different from houses in Eastville? Okay, is it because people have a preference for one against the other, or is it because houses in one district are bigger or older than houses in the other district? And we present you with a summary of the data and say, then, so the question is, what are the questions that you need to answer? Or what are the questions that you need to raise in order to answer those questions? Okay. What are the questions you need to raise? Okay. So in the question here is, first of all, are there differences in the price of houses? If there's no difference in the prices of houses between the two neighborhoods, which we are going to use statistical inference to decide, then the whole question becomes moot. Okay? You don't need to go any further. If the houses in the two districts are the same on the average, whichever way you decide about the sameness of the prices, if houses on the average price of houses in the two districts are the same, then the whole question becomes moot, because the question is, are there any differences in the price of houses? If there's no difference in the price of houses, there is no debate. There's nothing to discuss. But suppose you find out through statistical analysis that houses in one district are more costly than houses in the other district. Then the next question becomes, is it because houses in the more expensive district are bigger or are older. All right? Now, so now you go on to then measure the average size of houses. If the average size of houses are exactly the same, but the prices are different, then you could then infer that there is a pure preference, because if houses in District A are the same size as houses in District B, but houses in District B are more costly than houses in District A, that means there's a preference for B. And then you can now raise questions as to why this preference exists. And they also become things to measure and analyze statistically. The reasons behind the difference in average price of houses. This is how to reason and think statistical methodology. Okay, so this is the way you're going to look at the question in that discussion forum. Okay, the other assignment requires that you do some calculation. Okay, and I'm going to try to walk through that calculation just to give you an idea. Okay, it says use Excel to calculate the average age of houses in each neighborhood and save that in a new file. Okay, and then it says the Carlos argues that houses in this neighborhood sell at about the same average price. What do you think? Okay, now, would you rather say to Carlos that prices per square foot is about the same in the two neighborhoods? So essentially here, we're going to go through something that you already know how to do, how to calculate averages. So I'm going to just do one of them. I'm going to calculate the average age of houses in the two neighborhoods. Okay, I will pull up an Excel file. Let's see. Okay, here is the Excel file. All right. So the first thing that you do, excuse me. Okay, the first thing that you do is to sort the data. As you can see, the variable neb defines neighborhood, and that is explained in the assignment. Neb defines neighborhood. And there are three neighborhoods here, okay? Neighborhood 1, neighborhood 2, and neighborhood 3. So you can see them. We call them Harbor, Westcott, and Westlair, all right? There are three neighborhoods. So in order to compare, you have to sort the data in the neighborhood. So here I'm going to sort the data in the neighborhoods. So I will go data, I'll sort, and I will use neb as the sort criterion. And so you can see that all houses in neighborhood 1 come first, then neighborhood 2, and then neighborhood 3. Okay, easy. Now, I'm going to say, what is the average age? The average age of houses, this house was built in 1930. This house was built in 1950. All the houses were sold in 2009. And so you do a calculation using equals B2 minus E2, the year built, B2 minus E2, all right? And that gives you 79 for the very first house, and all right. So here you have the ages of the houses, okay? So I take it that Harbor is neighborhood 1, Westcott is neighborhood 2, and Wesley is neighborhood 3. And so what is the average age of houses in Harbor? Okay, so we use equals average bracket. So this is, sorry, equals average bracket. And so the average age of houses for neighborhood 1, we keep going until we are done with 1. So the average age of houses in neighborhood 1 is 68. For Westcott, we go equals average bracket. We start from neighborhood 2. We highlight the age, and we'll go until all the 2s are gone. All right. So the average age of houses in neighborhood 2, so we call this average age. Okay. I'm going to reduce the number of decimals to 3. That's just my choice. You don't have to. And for the other neighborhood, equals average bracket. We start from 3. And so the average age of houses in Westlair is 53.8. That's it. There is nothing heroic about what I have done. Now you can, this is neighborhood. Okay. And so you can plot a chart. You highlight, insert, kind of chart you want, and you have, you can age, name. And so now you move the chart into its own location. You can see Harbor, Westcott, Westlair. If you click here, you can add other labels you want. All right. You can add a chart design. Right click, add the labels, give it the color, solid fill. I'll make that red. Okay. That way you can see it. Increase the font size. Right. Bold. See, it stands out. Okay. Stands out. You can format everything else. And I ask students to copy and paste into MS Word. You copy it. It goes into MS Word. So it's easier. You can see everything now stands out even clearer. And that is the kind of thing I would like to see. Okay. I would hope that when I post these lectures, you're going to be able to follow what is done here. You have the opportunity to view it over and over and over. In that way, it's very clear to you. All right. So at this point, do you have any questions? Hello?
Yeah, sorry, I was looking over something. Yeah, I am. I'm understanding.
Okay, so it's very clear to you what I just said?
Yeah.
All right. Okay, since you don't have
But
any more
I was
questions.
gonna say that for the homework for the assignment instructions, it didn't say anything about doing a graph.
Okay, fine and good. But in future assignments, you will be required to do charts.
Okay.
Okay. This is why I went through it. I mean, I'll still go through it in the future, but it's simply said to prepare the averages, and you can see that the average was done in a table, and I'm going to pull that up again. Okay.
Okay.
Here, go to sheet 1. And so it didn't say do a graph, but you need to copy this out and put it in Excel. I mean, in MS Word for me. For example, okay. All right. You put it there. All right. And so it would be nice if you put the average age and the average other thing on this side and the average other thing that was asked for on that side. In that way, it looks neat. Okay. It looks very neat. And when you go to the workplace, one of the things that they're going to judge you is, by your presentation, your ability to be creative in the way you do things. Okay. You might just know how to calculate the averages, but if we're asked to present a report, how neat is your report going to be? You get it?
Yes, I get it.
Okay. Okay. Any other questions?
No.
Okay. All right. So thank you very much for coming.
You're
So
welcome.
I'm going to post this for the benefit of others. So if nobody comes, I'm not going to give any lecture, but I'm going to remind everybody that I'm going to give these lectures. And so it's in your interest to attend.
For the upcoming modules, like for instance, module 2, isn't there going to be a video again, like to help us work on the Excel problem?
Yes, absolutely. If there's no video, I'm going to give a lecture on how to go about it.
Oh, so if there's no video, then I could just get onto office hours and you'll explain it.
Yes.
Okay.
All right.
Okay.
All
Yeah.
right.
Thank you.
All right, then. Have a nice evening.
You too. Yeah, bye.